Good day to our future biotechnologists. We are from Group 3, Subgroup 3 will be presenting our chosen title for the Journal Reflection Assessment, Cost-Effective Treatment of Swine Waste Through Recovery of Energy and Nutrients. Before we go further, did you know that over 40% populations of the world would consume swine meat and causes the increasing of swine waste production? Waste from concentrated animal feeding operation CAFOs generate large amount of waste with high levels of organics, solids, pathogens, phosphorus, nitrogen, and potassium. This has become a threat to the environment. Conventional treatment of CAFOs with uncovered anaerobic lagoons require lands and associated with odors, attraction of insects and rodents, as well as emission of greenhouse gases with poor effluent quality. Therefore, this study is conducted to analyze the performance and life cycle costs of alternative systems, which are in-vessel anaerobic digestion (AD), followed by Struvite Precipitation and ion exchange (IX) onto natural zeolites, and single reactor approaches for precipitation and ion exchange (STRIAX) for treating swine CAFO waste for energy recovery as biogas form and nutrient as soluble fertilizers. Here, we will show you how the alternative technologies are used to treat the swine CAFO waste. The first alternative is AD Struvite IX system. This alternative involves three separate steps, which are anaerobic digestion, Struvite precipitation, and ion exchange. In anaerobic digestion, the experiment started with lab-scale mesophilic anaerobic digester for treating swine waste. Swine waste were mixed together with groundwater waste. The effluent from lab-scale anaerobic digester transferred to the pilot-scale anaerobic digester and operated semi-continuously by feeding the swine waste 3 times per week from top of digester. The effluent withdrawn from outlet at bottom of pilot-scale anaerobic digester. Collected effluent taken for the next step, which is Struvite precipitation. In Struvite precipitation, the effluents collected from previous digester were centrifuged to separate liquid centrate from biosolids. The liquid centrate was added into batch reactor for Struvite precipitation. Natrium hydroxide applied to raise the pH up to 8.5 for liquid centrate during Struvite precipitation. The centrate from batch reactor was centrifuged again to remove solid precipitate from solutions. The precipitates were collected and ready for the next step, which is ion exchange to retrieve nutrients while the solutions remove as clean water. In ion exchange, precipitate from Struvite precipitation undergo ion exchange tests for nitrogen, phosphorus, and potassium recovery. Hydrochloric acid was applied to reduce pH from 8.5 to 7.5. Natural zeolites were added for ion exchange process. A mixer was utilized to mix all the components. Zeolite will be collected and nutrient analysis is conducted. The second alternative is using single reactor called STRIAX system. For STRIAX, the effluents collected from anaerobic digestion step and natural zeolite were added into mixed batch reactor and allow Struvite precipitation as well as ion exchange occur simultaneously inside mixed batch reactor. Ion exchange reaction provide necessary of pH changes for Struvite precipitation without the needs of adding HCl and NaOH. Natural zeolite retrieved for nutrient analysis. Life cycle cost analysis (LCCA) is performed to evaluate economic feasibility of two proposed systems. Both proposed alternative systems showed high biogas production, about 60 to 70% of methane retrieved. Higher nutrient yield was observed, in which retrieved total of 90% nutrients from swine waste compared to conventional swine waste treatment. Overall, STRIAX system is more cost-efficient compared with conventional system or AD Struvite IX system. However, both alternative system requires large scale for financial attractive when compared with conventional system for treating swine CAFO waste. Now, let's talk about the benefit of these treatments. Not only it is a cost-effective treatment, it also an eco-environment treatment where, instead of dumping the waste into the landfills and produce greenhouse gases, it retrieves beneficial nutrients in the waste and recycle into valuable energy and nutrients that can be utilized in other sectors. Biogas is utilized for generating electricity for farms. Biosolids and nutrients can be sold as fertilizers. These treatments also enhance the improvement in water quality. Based on this study, this technology is known as a clean and safe way of handling swine waste, with no detrimental implication for environment nor human health. However, there are also limitations that need to be considered. Expertise is needed to conduct this new treatment as it would differ from the conventional method. Besides, in-depth research is still needed for this treatment, especially if we want to apply it on a larger scale. There is also possibility for this treatment to be a religious issue, since the clean water was previously mixed with swine waste, and the waste was converted into fertilizer where majorly will be used on crops. The alternative treatments also incurs high capital cost compared to conventional system. Increase in salinity through the treatment process of Adib Struvite IX system can cause potential issues in reusing the reclaimed water. So what can we do to solve these issues? We can use alternative materials such as biochar made from anaerobic digestion biosolids of the system to replace natural zeolites. This may serve as a more cost-effective and environmentally friendly ion exchange material. Hence, not only we can reduce the cost, but we can make this treatment as free waste treatment where the byproducts produced can be beneficial. Besides, further research on Adib Struvite IX system is necessary to determine the effects of cycling reclaimed water on the treatment system and the number of times the water could be recycled in this manner. And that is the end of our presentation. Thank you for your time and attention. See you again!